Hi, everyone. This is Sebastian Traeger, Managing Director, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today we are excited to be joined by Reuben Walters with Ego Pharmaceuticals. Thank you, Reuben, for joining us. We really appreciate it.
Yeah, my pleasure.
I feel like the first question I need to ask is you seem like you have a bit of an accent. Where are we doing this podcast from?
I'm in Melbourne, Australia, so the southeast of Australia.
That's great. We're in Richmond, Virginia, which is just south of Washington, D.C. So we're pretty close to opposite edges of the world. So it's great to have you join us. We really appreciate it. Thank you for doing that. I always like to start off by just understanding a little bit more about what company you're working for and what your role is at that company.
Yeah, sure. So I work at Ego Pharmaceuticals, which is a skincare and cosmetic company. So we make therapeutic and cosmetic skincare. We export all around the world. Unfortunately, not to America, but we're 50% selling into Australia, and then 50% is exported around the world, around Asia, the Middle East, and into Europe as well. So it's everything from hand sanitizers, sunscreens, moisturizers, face creams, and everything in between.
Great. And what is your role there?
My role is the engineering manager for projects, but for a few years I was the reliability manager as well. And I've been at the company just over 10, not quite 10 years, almost 10 years.
Okay. Excellent. I always love hearing and I love sharing with our folks what got you into reliability engineering and how did that become the path you went on in the journey that you went on?
Yeah, it wasn't the plan that I had. I studied chemical engineering at university with some computer science on the side. And when I started at Ego, I was a project engineer working on small and medium projects. And then I was tapped on the shoulder to head up a new position of reliability manager. And while they didn't touch on a lot of that in university, I definitely couldn't do my job without my degree, but there's so much that they don't teach you. And a lot of that reliability stuff is not in a chemical engineering course. Might be more into the mechanical and mechatronics or advanced manufacturing, but in chemical engineering, it's not so much there. So really, I did a lot of learning when I stepped into that role, which was really valuable for me to really just understand the basics of reliability engineering.
That's great. It sounds like you've, from there continued to do more and more things. Well, we know that you spoke at Mainstream Summit UK and spoke on, driving performance and applying reliability principles to cutting costs. Share with our audience what your main points were from that talk and what you feel like are, some of those ways you can cut costs.
Yeah, so it was the Mainstream conference in Melbourne, not in the UK. So I didn't travel to the UK, thankfully, but it was locally here in Melbourne. So the point of that was actually just to give some of the highlights, some of the wins that we've been able to get across the board over the last couple of years and getting really those basics right. So I had 3 case studies of some of the things that we've done. One in our utilities department, working on our purified water system, so a main ingredient in a lot of our products, upskilling our maintenance team, allowing them to do maintenance, and then removing ourselves from reliance on our external contractors. So that was one of the things that we've been able to do. So upskilling our internal guys. Another one was in our packing hall where we re-engineered a certain part that was just causing excessive wear. It took a long time to repair when it went wrong and it was quite costly. So we re-engineered it so that the wear parts were really easy to fix, really easy to repair. And that was all done in-house as well. And then a third one that I talked about was in our manufacturing plant where we have spray balls that clean a certain vessel and we were having spray ball failures quite frequently. So they would either stop working or they would fail in a variety of ways. And we didn't understand why until we applied these reliability principles of tracking recurrent issues and tracking these breakdowns that we found out that we actually weren't doing what we were meant to be doing with the spray balls. And that came from a reliance on our OEMs, so original equipment manufacturers and their expertise. But there was assumptions that were made that they actually understood the system and how it was meant to run. And we had to combat some of those assumptions to actually get to the root cause, which meant changing up how the process ran to be more reliable.
That's great. I want to focus on that third one really for a couple of reasons. One, it relates really closely to what our company helps people with, root cause analysis, but also just sounds like it required some digging deep on the problem. So can you just share the kind of the before after what was happening and what the cost impact or savings impact was of figuring that out? And then maybe share a little bit more about the process you went through to get to that root cause.
Yep. So just for some more background, so we've got a lot of mixing vessels, and each of them has 4 to 8 different spray balls because it's got a big mixer in the side. So it has to clean from a lot of different angles. And if one doesn't operate properly, we can't clean the whole vessel. And because we're a pharmaceutical site, we need to be able to guarantee that our vessels clean well every time. So when that doesn't happen, there's a deviation, and there has to be some analysis. All right, why didn't that work? What happened? But that was going on for a while. And people kind of knew some things about it. It's like, oh, it's happening because of this. But that was just kind of a gut feel. It wasn't actually data driven. It wasn't based on any information. And we trusted our equipment manufacturer. We were cleaning with high pressure water. We're also drying with compressed air. So we needed our vessel to be dry afterwards. And that was set up from the very beginning. So we didn't expect at that point to say, no, they don't actually know what they're talking about. But we needed to combat that. It's like the cleaning with high pressure, no problem. Drying with compressed air, that was where it kind of fell apart. And we only identified that after we actually went through a root cause analysis. We sat down, we got maintenance people in the team, project engineers, process engineers from the manufacturing department. We got operators in there, all talking about the issue, doing a fishbone diagram and all those things, trying to work out, all right, what is our problem? Where is it going?
Yeah.
And it came down to our drying procedure. So the cleaning, that's all right. Drying, that's where we're having the issue.
Yeah, so it's interesting. Why was that a problem? I would think compressed air drying. I mean, I can understand assumptions are like, how can that harm the cleaning of it when it's just the drying? So what exactly was going on there?
So when you think of a spray ball, so there's a pipe going into a spray device that spins, and it's got gears in there, and these spray balls are meant to be lubricated. They're meant to be lubricated all the time. So with water, you're applying a fluid there and it's fine. But when you've got really dry compressed air, which we have, it doesn't have that lubrication, and it actually causes excessive wear on the spray balls themselves. So we've implemented it for some of our mixes so far. We're still yet to continue this work, but we want to finish the job, but it's still costing us a little bit of money. It saves us some, but it's still costing us some. We're on the way. But we need to dial down the pressure. And to do that, we need to open up all the paths for the spray balls at once rather than going one by one, which we do for water pressure to maintain the cleaning sprays from the spray balls. And in terms of a cost impact, so it was almost a maintenance spend of $20,000 per year just on replacing different spray balls. So there's a significant payback of just, all right, we need to get into the program, change how it works so that we can actually have these spray balls last for more than 12 to 18 months and actually last for 5 years. And we actually found that out by talking to the spray ball manufacturer and looking into their manuals to say, all right, how long are these meant to last? And what are the conditions that they're meant to be in, rather than just relying on the people who supplied the mixing vessel.
So that sounds like, if I'm doing my math right, you increase the life cycle by about 3x from 12 to 18 months to 5 years, the presumable runtime. And in each one has about a cost of about $20K, you said?
Not each one. So if a single spray ball failure could cost between $2,000 and $6,000. So depending if it was a rebuild or a complete replacement.
Okay. If you're saying like the potential impact is about $20K, what internally, why wouldn't you kind of fix them all immediately? What's the internal math that stops you from doing that?
The internal math is that we need to schedule downtime on the machines. I mean, to coordinate different software updates, we usually have them planned at certain periods throughout the year. I believe we've done 2 of the mixing vessels, and we're still waiting to do the 3rd one.
That's great. Thank you for walking through that in such detailed ways. That's just really helpful for our audience to hear a true case study of how you guys went from here's a problem, here's the solution, but it's nice to hear the intermediate step of how you all went around solving it and solve that problem. Are there other, examples you've got of a similar, well, you mentioned the 2 other examples that you shared. Talk to us a little bit about the upscaling of staff and kind of insourcing. What was that kind of problem, the process you went through, and then the result that accompanied that?
Yeah, so with our purified water system, we were heavily reliant on external contractors to come in to service our purified water plant and then to kind of make sure that it's operating up to scratch. but we found that we weren't getting the quality and the output from the purified water system than we expected. So again, we challenged these assumptions. It was like, all right, is this the way that we need to go about it? So toward the beginning of 2024, we upskilled our maintenance team members and myself included. We're doing a purified water course, and that was from a company through the US as well. Just understanding purified water. How do we maintain it? How do we clean it? And all those necessary steps. And then once we did that, by the middle of 2024, we were able to say goodbye to our contractors and actually maintain it ourselves. And then digging into the manuals for the purified water membranes themselves, we actually figured out that we're not cleaning it long enough. We're not doing it at temperature. So before we were doing it at room temperature, and then we started cleaning it around 30, 35 degrees. And that increases the reaction speed of the cleaning chemicals so that it actually cleans more effectively. We weren't doing a soak. We weren't letting it sit there for a while to kind of work its magic before getting rid of it. So we're able to implement just these small different things to actually really clean it effectively and get it better under control.
So 2 questions follow up on that. So presumably the third party contractor wanted to keep the contract. So why do you think when you came to them and said, hey, we don't think this water is clean enough or it's not doing what we're expecting, do you think they were just incapable of problem solving that with you, or they didn't want to, or they didn't understand they might lose the contract if they didn't?
It's hard to know exactly their thought process, but from my perspective, it was they've got a lot of different clients and they couldn't spend the dedicated time working on one issue. Like they're only spending time with this one day a month, but they've got all these other clients they're working with. And there are a whole host of purified water manufacturer or purified water plants around Melbourne. And because maybe we just didn't get the time, we also couldn't get the reaction time of if something did go wrong, we wouldn't get someone out to site until a while later, and we'd have to rely on one of our team members to fix it where they don't have all the information. Putting that
so it's
together.
just one of those cases where you found, here's a problem we're having. We think through this course, through upskilling, we actually can get the expertise we need. And that will improve kind of the response time and the quality of the water, purified water in this case. To some extent, how did you go about making that business case? Because that's effectively, you guys were investing in the upskilling before you knew if that was actually going to bear fruit.
Yeah. I mean, the cost of the contract was roughly like $20,000 a year. The cost of the training was in the order of $5,000.
Okay.
So it was like, it was a really low cost in terms of this maintenance upskilling, because it was an online training. There was, we didn't have to go somewhere to do the training. We could all do it and we could kind of work on it together. I mean, I just went to my manager and was like, all right, we want to do this. We want to upskill with the potential to do that. And just like, yeah, go ahead, go for it. I mean, great. That's such a low bar of entry. There was no downsides to doing that, to upskilling, and it provides more ownership as well for the maintenance trades to feel like they're getting more out of their own job. So it's not only benefit for the company in terms of output, but in terms of the people being invested in the equipment.
Sure. The morale. One thing I like to talk about, I was just at a conference myself and gave a talk on just kind of focusing on the basics, right? How there's so much power in any team that wins. It's usually not heroic effort. It's usually executing on the fundamentals with excellence over and over and over again. And that puts them in a position, of course, to have that like breakthrough. But it is so powerful when you do what you're describing, right? 2 projects that didn't have the largest cost associated, but just identifying a step you could take to make a difference, executing on that, and then seeing a result, seeing fruit from it, gave you guys confidence to do the next one. I love how you're using some of these kind of straightforward approaches, just good, thoughtful, disciplined approaches to make a difference. Let me change gears a little bit and just try to understand, because you're in a different part of the world than we are. What are you seeing as some of the more innovative things happening, whether it's in AI or IoT, and how those are being used, whether you're a skeptic or a fan or somewhere in between of some of those things?
I'm probably on the skeptic side of the spectrum, only because of what reliability is. And like one of your questions was about what is the most underutilized or undervalued. And I think that's the analytics and the qualitative analysis of data. It's like AI can do a lot with data. Like we know that, we can see that, that's coming out. But what it can't know is the machines. It can't know day to day, all right, I know that machine, I've seen that trend before, that does because of this. So it doesn't have that operator, that doesn't have that day-to-day experience. So one of the things that I get the reliability engineers to do is write a breakdown report. So every month there's a recurrent issues or breakdown issues report. And AI could probably write that report. That's not the problem. The problem is that if we get AI to write that report, who is getting the knowledge of actually understanding the machines? It's not our people. So I'm a big believer in we get the people to write the reports so that they can know the machines, so that they can respond to issues more quickly. They can understand them. They can talk to the trades. They can build those communications rather than just relying on a tool to build something that doesn't actually provide the value that you want it to add.
So are you optimistic though that over time, as AI is, basically that information can be collected from machines, so we have a better picture of what they are, and therefore the data models will help us even more on it? Or do you think no, it'll always be just a supplement to that operator's knowledge and a big help to them, but we still are always going to need that kind of knowledge and information?
So we are still working on getting data, and not just data for data's sake, getting the right data out and then representing it in the right way. So there's going to be a mix of AI and IoT stuff included in that, but it's always going to be operator and engineer molded so that it actually presents in the way that you want it to present, and it feeds internal knowledge rather than just being something that people can read but doesn't actually help that much.
It sounds like you really like the idea of when people do the work, they're gaining knowledge. Yeah. And by doing that, that's making them wiser, better at what they're doing. And yeah, the more they're relying on technology and don't really do it themselves, it's potentially going to erode that value that they provide.
Yeah. So when AI supplements learning, that's good. But when it creates shortcuts to learning, that's a gap that you're not going to get back. And that's a gap that people need to bridge that gap of that learning activity.
I like that. Supplement versus supplant, or supplement versus shortcut. That's great. Last question then. So just as you kind of think about passing on knowledge, as we were just talking about, to other reliability engineers, what's kind of one thing you would love to kind of pass on? If you said, hey, if I could rewind 10 years and start over, here's what I would kind of pass on to folks.
I would just recommend that people don't get distracted by the shiny new tech. Like, there have been reliability engineers who've been doing engineering for decades without it, and we've been doing it well. I mean, you can look at the reliability heroes like Toyota and all the Japanese manufacturers, like they know this, and they've been doing it without all the data tools that we use now. So it is possible to do without that. So we need to get the basics right. Even just thinking about the 80-20 rule. So we'll get 80% of the benefit doing 20% of the work. And I believe that the AI will generally help us get the final 20%, but it's going to require the greatest amount of work. So it's going to help us achieve more, but if it's not helping us achieve the 80%, then we're probably focusing in the wrong area. So it's just, are you focusing in the right place? So let's get back to basics, track the breakdowns, understand the machines, and go from there.
That's great. That's really helpful. And I feel like the case studies you gave us were right in line with what you just described, kind of that focus on the basics, know the machines, and solve those problems. Well, thanks so much for being with us today. We really appreciate it. And thank you for this insightful conversation. Again, this has been Reuben Walters of Ego Pharmaceuticals. And again, from Australia, we just appreciate you taking the time to do this.
Yeah, thanks for having me.
And to all listeners out there, and really anyone, we're about helping engineers and really anyone take steps to solve problems using technology and also using kind of common sense. So if you're looking for what our company does, RCA training or RCA software, we encourage you to check out reliability.com. If you want software to help you solve more problems, look at Easy RCA. And thank you for joining us in making the world a more reliable place. We'll see you on the next episode of Reliability 4.0. Take care.